welcome. How was that? Was that okay? Did you hear
That's
it?
awesome.
It had a little bit of public access channel to it, but it's all good.
What is the cowbell?
This whole thing is a public access show.
You know what? Look,
This is like Wayne's
Can't
World in
do
a
it.
basement.
All right.
I need
need a band.
cowbell.
You
I'm
need a
sorry.
band
I know,
behind.
Rick. I know, Rick. You want to basically bury the whole cowbell thing. I need the cowbell.
All right.
I'm sorry.
We'll rehearse.
Don't roll your eyes. I saw that. Okay. All right. What are we going to talk about this week?
SpaceX and the Crew Dragon, or
Yeah, that was pretty cool, right? That was pretty cool. That was super IoT.
Yeah.
Rob, you always talk about NASA and how they were the originators of the digital twin, right?
Well, just all that stuff, whenever you need to chill people out on their IoT stuff, it's like, you know what? I think we were getting telemetry from astronaut spacesuits on the moon like 50 years ago. And I think we send command and control to satellites and things that are interstellar now. So don't overthink it. We already,
Here's
also,
my super tiny piece. I don't know if you can see it, of the gold foil from the Apollo 11.
Wow.
That's
It
awesome.
actually has a magnifying glass to make the infinitesimally small piece look bigger.
That's
Space
awesome.
geeks rule.
That's awesome. Absolutely, they do. One thing I need to start out with here, you might be wondering about this outfit I have on. For my my good friend from Portland here, this is a company called Polar. I don't think they're open anymore. They used to have a store not like in the Pearl District, not far from Powell's, but this is basically a sleeping bag onesie almost. It's hard, you can't see. It turns into a skirt. You pull it underneath. There's arms. I can zip them back up. Anyway, this is great. Like if you go camping, because you can just wear it the whole time, and then it converts into a sleeping bag, and so you're good to go. So just in case.
Given future hotel hygiene issues, you might be wanting to keep that on, right?
Yeah.
Bad idea.
I remember in China seeing people like you right now with these sleeping on their desks, the naps, like siesta time after lunch.
Well, I mean, gosh, when
awesome.
I used to work at Microsoft, not like in the old days, I remember sleeping under my desk a lot at the office, actually.
Under your desk.
Writing code, man. But, the reason I do this is since I work for a Swedish company, I will find myself having to get up at ridiculously early hours, and I'm in my office, and then I do the call and then turn the lights back off, and I have this thing on, and I try to sleep for a couple hours until the next meeting, which might, it's weird. I'm off.
I just thought you were just going full Zuckerberg, with the hoodie up. That's pretty.
I don't know if I want to be full Zuckerberg these days.
Yeah, right. I wasn't going to say anything, but
All right. So digital twin? What is a digital twin?
There's some politics to those too, but we'll see.
Yeah, let's try to navigate the political pitfalls.
Rick knows more about digital twins than
no
anybody
kidding.
on the planet.
Oh yeah. Why?
Oops.
Why digital twin?
Well, no, for me, it's been an approach, right? It's like it didn't have a term or a word that we slapped on it, but it was, I did a talk like in the Wayback Machine about like an API for the real world. So that's kind of how I spun it at one point, that you could have an API that lets you interact with things and their data and so on. Well, when you give that some structure, right, then it starts to become what we think of as a digital twin, right? It's a manifestation of its data exhaust, its capabilities. And I think, I'm sure we'll dive into this, but like every one of us will have a different definition. And then everybody, every vendor's going to have a different definition. Whether you're coming at it from the physical product side of the view, like the really cool stuff that ANSYS and, PTC and people like that and AutoCAD, Autodesk are doing. Rob and I have talked a lot about a lot of us are very focused on digital twins for assets, right? Mm-hmm. That this is what that machine looks like, that thing, the electric grid, but the processes that they perform have a whole twin and a data exhaust and all that kind of stuff. The stuff that goes through them has a twin, right? What do you call a work order, or what do you call a production order in a plant? Anyway. So there's a million different definitions, but ultimately for me, it was just a way to do two things. One is to provide us a way to interact with those, some physical and digital manifestations of things in an equivalent way, in an abstracted way. And secondly, to identify things that were similar, right? That these are all refrigerated trucks, right? And all refrigerated trucks, it's like it's kind of a special version object-oriented programming, right? Or that they all some family of products all share some common set of characteristics. Things we're totally used to doing in the programming world for a long, long time with a lot of different tools. All right, what's the best way to manifest them in the IoT world? And now we have a name for it.
Yeah. I feel like my first inkling of seeing something that was, probably back in the late 90s, I was just doing contract work at Boeing at their commercial airplane group, and they were just bringing in CATIA from Dassault Systems, to design airplanes digitally for the first time ever. And so, running on not Sun Microsystems, who was the other?
HP Apollo and all the...
Oh, they're not in business anymore. They were where Google is today, literally the location. Jurassic Park. They made the most intense Silicon Graphics.
Yeah,
that's what I was thinking.
SGI, yeah.
Yeah. And so, I just remember being blown away seeing this 3D stuff on this CATIA system from Dassault Systems running on Silicon Graphics workstations. And you're like, wow, that's the future. And we're not going to use blueprints and paper anymore to design an aircraft. So that was my, your first inkling. And just cool stuff. No doubt about it.
It's that cradle to grave thing too, right? Being able to take it from, if you've designed a product digitally, why should you have to go to some other tool and recreate like all that information? Actually, it applies even, I'm sorry I missed the smart city stuff, but a smart building or a smart city, you've got some GIS system or, building information system that had the architectural drawing. There's stuff we can, start from to build that and then annotate it with all the data. The other side, I think that I haven't seen a good standard approach for is we do a lot around digital twins around data, right? Here's the properties of it and what's going on with it. Not so much with what it can do, right? What capabilities does it have? What services does it provide? We don't do a lot with like the historical data exhaust and how you can kind of access that through the twin. And, we have some back and forth on LinkedIn this week, but I don't know if we'll ever get to a standard, but can we get you some consensus from people on the API models, right? Just a way that we can, your digital twin and my digital twin don't have a huge impedance mismatch.
That's a good point. I remember distinctly, maybe a year into doing the Lumada thing at Hitachi. And so we had our asset avatars, which were our twins. And then we started working with SAP. And I remember them coming to us in Santa Clara and me going to Waldorf because they were introducing Leonardo at the time. And they had acquired, I think it was a Norwegian company, to give them digital twin capabilities in Leonardo. And to your point, we were spending a bunch of time saying, how can your twins and our twins, talk to each other, or how can we migrate our model to your model? And that's just two companies trying to figure it out. You can imagine it's like everything in life, right? When you start a new space, it's just a free for all, and you're going to have a zillion players. And you're right. You just say, well, I've just decided this is how twins are going to work, and this is how they're going to look, which I'm guilty of because I like to just decide things and do it instead of waiting. But, then you have the Wild West, and it's a big mess until you get some kind of standardization. I always joke when people say standards and IoT. There's no such thing.
Well, let me, as the SVP of IQ, and by IQ I mean of ignorant questions, not the intelligent.
No, jeez.
would you agree or disagree that if we lived in a world where, using Rick's example, it's like, hey, everything is like an API. So you have a bunch of digital twins that have been deployed in different environments. Let's just go with refrigerated trucks in Northern Africa. And I meet with a company that's doing refrigerated trucks in, Russia. And we had a way to talk to each other. Isn't that the recipe to accelerate whatever model it is that you're looking at? Because I've got this massive aggregate of data without trying to figure out, well, you need to buy my twin and take my standards so that I can give you this. Am I thinking about this correctly with only a few sips of coffee?
Yeah, but
the REST API, no?
Yeah,
exactly. But you still need adapters, right? I think the other mistake about the IoT, particularly industrial, as you get more industrial, is the amount of brownfield, right? You're not going to rip out all of it. So you need to be able to wrap existing stuff to have it interoperate with this, the rest of it. Look at home automation, right? I've got all kinds of weird stuff from a variety of different vendors, but for the most part, I can operate it off from a handful of applications. Somebody did a lot of hard work to deal with all the proprietary crap that's behind that, but it's a little more effort, of course. In a perfect world, it would be plug and play.
Right.
That's a whole nother rabbit hole we won't go down. But
Windows 95, we brought it to you, baby.
That's right.
You know what? It's all about wrapping. You're so right. Most of the world is brownfield. It didn't turn out to be this greenfield nirvana at all, and so it's wrapping. And remember, we started wrapping things years ago. Wrapping APIs when SOA it was a thing, and SOAP and XML, and people were wrapping. And REST came along, and I'm wrapping a mainframe so that web pages can talk to a mainframe. I'm wrapping all this old stuff, and I think that's a common thing just in IT, and we live in a world of not only old machines and stuff in factories, but every company is full of just legacy stuff everywhere. Because as I've learned, software apparently never dies, and no one upgrades anything, as it turns out. And no one modernizes anything. We talk a good game. No, I'm going to still have my AS400 cranking along forever. Or I've seen companies running their whole supply chain management thing on OS2, running in a VM, running on Windows XP to get support.
XP?
Absolutely. That's the real world. As it turns out, IT guys don't want to spend their budget on modernizing or upgrading, even though they talk a good game. They would rather have the old stuff somehow, creaking along. That's why the whole, and I don't want to get off topic here, but don't forget, the entire financial system on the planet Earth is still mainframes and COBOL. Nothing's changed.
But that's not off topic at all, because fragmentation is something that never goes away. Even if you establish a certain type of standard. I mean, look at SOA. SOA, they were pitching SOA for a really long time, but it took a very long time for the principles to really start to make sense to people. And in terms of implementations, very, very difficult to implement at an enterprise level, right? So you had a lot of enterprise architects going around trying to sell the idea of service-oriented architectures in their organizations, their IT organizations. But then what they found out is exactly what you're saying, Rob. There's just so much fragmentation and technical debt loaded into these portfolios. You have to really start to think about integration and middleware. We talked about middleware, I think, in the second episode. That becomes important and actually is the thing that kind of persists. And so, back in the day, you had like Vitria and Crossworlds, and the key features that they would go to market with were all these different adapters for all, you had adapters for Oracle, adapters for SAP, and the whole thing was about, resolving the semantic differences in the data models and the data definitions for different transactions or things even back then, right?
They're no different. Absolutely.
Yeah. And then just make everything talk in a hub that kind of resolves everything and makes everything talk nice. But of course, in this age where we're talking about low latency applications and innovating on top of an infrastructure that promises ultra low latency communications, you can't have that middleware overhead in certain situations, right? Or for certain types of projects that you might aspire to realize in real life. So,
in-memory middleware.
Yeah. Hey.
So back to the
in-memory computing.
The digital twin thing. I always, right or wrong, I always like to say, hey, it's like that owner's manual you get for your car. And here's everything to know about your car and all the sensors and how much gas your car holds and a million different things and when you need to service it. I always love to use cars to describe digital twins because it's something everybody seems to understand. And as Rick was talking about, a lot of times you'll have things that are all the same as each other. You have a model of a car that's the same, and then you have the instances of your version of that car and her version of that car. Mm-hmm. And then all the attributes, And so right or wrong, some of us, like since I'm a developer, I kind of think of all that stuff like OO programming and base classes, inheritance. That's how I've always looked at it. And actually, I remember when I was hanging out with the SAP folks trying to do that stuff, as it turns out, they thought the exact same way. That's kind of where their thinking was too. And so, it's like this object, right? And you're right, it's got properties and maybe it has methods.
Well, real world example, this weekend I drove my friend's Model 3, right? And I kind of checking out the vehicle and what it's all about. What a great example, right? You've got a very simplistic physical dash, almost non-existent. Everything's its digital representation. As you look at the way the camera systems are detecting vehicles, you have a live digital representation of the entities around you. All of the state of the vehicle and its systems is represented digitally. And it reminds probably maybe 2011, I forget when the first Tesla APIs came out. I didn't own a Tesla, but someone at our company did. And they had an API from the get-go. So within, I'm not exaggerating, like 4 hours, you can set up all the OAuth and all the crap to get you connected, but you're changing the AC setting, reading the battery, opening the window, beeping the horn because it had an API. If more products, kind of came with an API, I don't know why they're, it's different than letting you change the firmware and crap like that, but it just seems to be, it enhances the value of a product intrinsically, even if they're not all the same. They don't follow the same patterns.
Yeah.
That's great, but it's better than no interface at all.
No, you're absolutely right.
Well, it's a design, obviously it's a design decision, but also, in my view, it's like, you know what, we're going to make this amazing piece of equipment, but there's some things that we just won't get to do. Let somebody else do it, but use the vehicle. Because now there's an inherent value of, in this case, of this Model 3 to an audience that is not the car buying audience, but that could be monetized, even if it's 1/100th of a penny per API call. But then again, that guy Elon, I heard he's some sort of a genius, so it makes total sense.
Well, did you see? I mean, look inside the view of Dragon 2 capsule, right, and compare that to like the Apollo capsule.
Yeah,
I know. I've been seeing those pictures going around.
Mind blowing.
It's crazy. But so, there, I like the idea every product's being delivered with a digital twin of that product and APIs and everything. And if I think the most baseline thing you could do in IoT to add value without crazy stuff is just the fact that I'm an OEM and I make a product and I deliver a digital twin that describes my product and there's APIs and I as an OEM can retrieve that data or the customer can. And I'm just going to use that data to stay ahead of problems, and I'm going to see usage and performance and errors and faults and whether this is hardware or software. And it's just basic stuff. You do it, and then your product improves over time. You see, oh, it turns out they only use this part of the product and they never use this other stuff we built, or this is failing all the time when this happens. Or at 60,000 miles, the fuel pump always goes out on this car. Maybe this whole fleet of cars of twins has the same problem.
This is why the mythology of of like, I think it's mythology. The IoT is all going to be the devices connected to the cloud, a cloud. There, a huge number of the implementations I've been involved in over the years had a significant cloud-to-cloud segment, right? Where a vendor is doing that data aggregation into their IoT cloud, but then you need to kind of federate those together to do useful stuff. So it's not just about like figuring out how these things interact from edge to cloud. It's cloud to cloud. How do you do that reliably, securely, all that fun stuff, right?
Yeah.
There was an announcement this week. Samsara just said, that they partnered with Ford, and I dug into that. It's a great example of what David was saying, that they have an offering. Ford has an offering for fleet management, but they also have a data services offering, so that there's partners can build fill gaps, add new capability. That's it's a very progressive model.
Who trademarked this concept of digital twin? Because I think that we talk about IoT, nothing else, and someone else trademarked this concept of digital twin.
Yeah.
What do you think? Because I remember 3 years ago, probably, I went to visit a customer, and they told me, they had like some hundreds of devices connected already. And they told me, do you provide a digital twin feature? Like, what do you mean? What is digital twin? So he started to explain me, digital twin is this. I went to a conference and they explained me that digital twin is important. And I was like, yes, yeah, of course. Everything that you actually explained me, it's supported, no? We have APIs. We can do this cloud-to-cloud communication, et cetera, et cetera. But yeah, there was, someone, I don't know who, like edge computing concept or fog computing or things like that is invented by someone to just name or brand, something. No, but we are talking about the basic IoT, I think.
I could always tell which competitors were in just before me from those loaded questions they would ask, right? Do you have feature X?
Yeah. Just tell them it goes back to Tom Hanks and Gary Sinise in Apollo 13. That's the best way to describe why you need digital twins. When those guys are trying to get those guys home on that.
Rob, I thought it was Forrest Gump.
Forrest was there in spirit.
They were together.
Yeah, but I think Marc is making an interesting comment there, because it seems like digital twin is just the OT world discovering object, like what you're saying, Rob, object-oriented programming and data modeling. It seems like it would have been an inevitable organic evolution of what folks were doing in OT as IT concepts started to merge and become more readily available to the OT universe, if you will. So, but yeah, I guess you have to come up with buzzwords for everything, But it is interesting to hear people sit there and talk about digital twins, and that it's this whole revolutionary new thing. But it's like, okay, well, we've actually seen these types of things before. It's just you're describing something that's already been there, but you can't. It's not that it's new. It's maybe a discovery for some folks who are not familiar with these IT concepts.
Or a clarifying term, right? So sometimes it's just a way for people to have a common vocabulary to talk about something.
But it's just vocabulary, as you said, so nothing else. So when you have to connect with another company or system, it's still something completely new. You have to agree on APIs, on protocols, and payloads.
Well, it's like IoT. IoT's been there for a long time. Right. For a lot of people, IoT is, okay, is that what you call it? Right. Okay. Well, IoT, and we can brand it and come up with a forecast about how it's going to be a gazillion-dollar market opportunity and make dinero.
Where's the money?
So, I have no idea.
Show me the money, Jerry.
Show me the money.
The other thing with with all of these things is like this again, mythology that it's all about the device, that the digital twin is the device. That's part of it. Yeah. But the useful, like, digital twin, you were saying it spans IoT. It's like, give me a way to get the composite view of all the stuff about that entity, right? And I think a lot of companies are taking it very linearly and simplistically.
Yeah. No, you're right.
You're absolutely right. I mean, the devices are, at least the sensory devices, in the nervous system, right, of the implementation, and then there's the object, or even the space. Like you talked about smart buildings, or even smart campus. It's how do you sit there and characterize spaces? Because, you know, Rob, you and I talked about this back in Barcelona, right? That, you know, digital twin could be actually a space or an environment. So, it takes a little bit of mind bending to think through all the different kinds of digital twins, and then the role of the device, right? But Rick, I totally agree with you. I think people get the device confused with the digital twin, which then is all that object-oriented stuff that we've been living with for quite some time.
Yeah, but you know, Leonard, but really mind-bending, I mean, it's such a simple concept. And look what you just said. So in the context of let's just go office building, digital twin. So imagine the enterprise that had, you know, millions of square feet of office space before COVID. And for whatever reason, they had a digital twin thing because of whatever. What would those folks do now with the ability to digitally read to and reimagine what they're going to do with that space versus those who don't?
Yeah.
And so it's not a hard concept, but maybe it gets thrown with all those buzzwords, and then no one really knows what it means, or we all have different definitions. So, you know, maybe there's a joint responsibility of folks like us and our ecosystem of just calling it for what it is, mirror environment, or, hey, here's a way, to Rick's point, how do you, represent it in this way? And there will be so many benefits. Sore subject with owning millions of square of, real estate that are not being utilized right now. It'd be fun to start planning a way right now to digitally do some exercises to make sure that folks are comfortable coming into this environment. Again, no different in a factory. Is the distance that that Leonard and I would have packing meat is very different than the distance we would have if we were putting F-150s together, right? So how do you take that in account? And digital twin would make that so easy and rant over. That was it.
Which implies people have a digital twin too, right? That's one that gets lost.
Rob.
And then the third one, I guess it's the fourth, right? We talked about the assets, the processes, people. The other one that spaces, factories, electric grid, quickly surface is the importance of a digital twin model of the relationships between things, right? This thing's connected to this one. And these are transient, right? That could be very, very, these vehicles are on this road at this instant, but there's proximity. When we originally did ThingWorks, it was all built on a graph data model for that reason. I don't know why, but it just sort of feels like this is a graphy problem. We ended up backing away from that because we found that at the time, it'd be great if everything was theory, but you still have to actually make stuff that people can use. And it was very difficult to allow people to ask questions of a graph, right? I think that's evolved quite a bit in the decade or so since then. But that's another piece of the puzzle that I think, if done well, will allow us to kind of answer some of those questions and interrogate very complex networks of things to ask questions. But it's another part of the digital twin.
So for the record, you came up with explainable AI before we were talking about explainable AI. How do you explain it?
Yeah, I don't know. It's magic.
Open the pod bay doors, Hal.
But this reminds me some of the discussions we had on LinkedIn, launched by Leonard some weeks ago or some months ago. Now, if a human is developing a digital twin model, So what answers? No, what answers will answer? No, from or what questions will answer, and so that the answers will be what these developers have been developing all the time. It's like I like to compare this with the allegory of the cave of Plato. So the reality, it's what the people that was jailed into the cave, they thought that the reality was the shadows, not that they could see at the end of the cave. And so sometimes I see some, call it digital twins or whatever model. Sometimes I perceive that some systems behave like that, like that prisoners inside the cave. That they see a reality that it's not 100% real, that it's a fake reality. Because we are humans, we develop these systems. So we need to go to the dentist with children. We are in a lockdown, or thousands of things, So it's tricky.
To have like a well educated in fake reality these days. That's for sure.
Well, I think we need to make a distinction between fake and then augmented. So that's tough.
But we talked about the obviously the lockdown, the COVID. We got people, patients. We may have talked about it before. I know I spent a lot of time. I'm involved with this healthcare organization and spent a lot of time just talking about digital twins for patients, and using the same concepts that we talk about with machines and systems and things like that. There's a twin of the patient, but their heart is so complex, it deserves its own twin, and it's a subsystem, and it's an parent-child relationship with the whole body, and your lungs deserve their own twin, and all that, you get it, the brain. And getting to a point where we're able, obviously we're monitoring, we've got smartwatches and all kinds of things. We're monitoring more and more of human being. But you can imagine healthcare is getting pushed forward in a big way right now, and it's going to have to revolutionize. I often think, and I might be in left field, when I think about opportunities around IoT and digital twins, I've been thinking healthcare more than anything lately. For sure, because the focus is certainly on that in a way that hasn't been in the past. And so representing kind of the things we're all talking about, whether it's people, their subsystems, their ecosystem of who they're dealing with, they're just like an industrial robot on an assembly line. The assembly line is a twin that just looks like a group. And then anyway, now you got people working in spaces in a building. Can they be this close to each other? There's so many things to figure out. But maybe twins of people and systems might be helpful. I don't know. I don't want to overcomplicate things.
Well, they are, and this is exactly where the wrapper is. So that the difference between the purist and the pragmatist, and the practitioner. In a perfect world, we'd retool every system and it would all magically interop, and that's never going to happen. But there are very practical reasons in healthcare, in manufacturing, where you're not going to change the code in those systems because there's risk, right? You have to recertify your MRI machine or the infusion pump or whatever. So if we want to do that, we have to come up with ways to, in a non-intrusive way, allow them to play into this cool new digital twin world. And that's, I think, if there's one takeaway I have from my experience, is the importance of that, and that you just can't count on being able to touch, swap, modify stuff that's there. Even products in the pipeline now, right? They're working on vehicles, medical equipment that it's locked down, and we won't even see it for in the market for 3 years.
Yeah, that's a good point.
Yeah. So one real quick question. So have you guys seen these gaps in data or in, let's say, a portfolio of digital twins where, to your point, Rick, where you're not able to instrument a certain thing in, let's say, a shop floor that is critical, that creates a huge data gap, a hole in the whole architecture where you literally can't do certain things just because you can't see something with the level of the velocity of data or the veracity of data that's needed for an application?
3 really cool things I've seen in that. One is, obviously, let's take the easy one. It drives a business for retrofitting, right? For adding that sensing.
Yeah.
Second one, which I thought was kind of cool. I remember working with this guy in the power industry, and they had the sensors, and they had analog, physical displays, right? They just weren't connectable. You couldn't communicate with them. So he did these things with little cameras that you've probably all seen these, but the camera reads the analog gauge or the digital gauge and turns into a digital signal. Sounds crazy. It's simple, but it solves a problem, right?
Yeah.
And the third one that's increasingly becoming viable is synthetic sensors, where you can through machine learning and other techniques, can characterize a piece of equipment or a process or whatever, so that you can actually backfill. There was a company, I think it was in the early 90s, mid 90s, that when you're trying to measure emissions, for example, coming out of a smokestack, very expensive sensors, expensive catalysts, need a lot of service. And what they were able to do is come up with digital models. This is kind of AI and machine learning, that ultimately got accepted as just as valid as the actual sensor. So they essentially eliminated the need to measure those. Obviously, they had the sensors in during the learning phase and modeling phase, but then they were able to take the sensors out. So there are a lot of interesting ways that we might be able to use technology we have today to mitigate that.
So, hey guys, I'm like out of coffee and I'm wearing shorts. So why don't we call it a wrap for this week? And I think next week we're going to talk about edge computing or something. Hopefully we'll have Nancy and Stephanie on. But I thought this was a great conversation. Maybe you guys want to do like a part 2 of this one of these weeks?
Yeah.
I think we could probably go on forever on this topic, right?
How about maybe what's not a digital twin? Like what should the people that listen to this, the buyers that listen to this, call BS on, because it's not a digital twin, but it's being wrapped and sold as a digital twin. Hey, this is for the community, right?
Ooh, you're getting psychedelic, bro.
I'm ready to go.
I didn't see my royalty check from last week, so this has to be for the community. So let's call it for what it is.
Head trip.
Actually, I wanted to raise a new topic, that it's how to hack a digital twin, because I wanted to bring some examples here, but I can bring them into my pocket. Some coffee.
Robin is digital heart, privacy and security. That's something we got to hit too, big time, right? I hate it when people say, well, it's because of privacy and regulations you can't do it.
No, but imagine that the price of a good depends on something that has a digital twin. Okay, for example, let me give you an example, and it goes into your coffee. Actually, we were working on a project digitalizing coffee plantations for very high quality coffee. So actually, if you don't know, coffee, it's super scientific. So it's like super science.
It's like wine.
And if it's in that altitude, in that position, it rains that amount of time, etc., etc. The quality, it's 99%. If something changes, it varies, but it's super scientific. So actually, we were thinking how to hack. So the quality of the coffee actually applies directly to the price of the coffee. So now it's not digital, all of this. So actually the farmers can understand that if it rains more than last year, after the third moon, probably the price will decrease. So why we don't go to all the sensors and put an umbrella on the top of the rain sensors?
Okay, that's awesome.
I mean, it's not about privacy or security. Well, it's security and privacy, no?
Well, and data integrity. It got to be in there. Data integrity. How do you prove it?
Yeah.
Exactly. How do you prove it? And how do you know that the quality of the coffee it's 99 and not 98 or 97.5?
I'll finish with a funny story about Smart Ag about that. To wrap up is so we did this very lengthy analysis in 2013 where we fed all this agricultural data through this very sophisticated machine learning model to try and predict soil moisture. And after days of crunching and training, the outcome was if it rains the day before, the soil is more moist.
Boom.
Insight.
Okay, guys.
Keep it simple.
All right.
Who knew?
Yeah, keep it simple. All right, keep it simple, guys.
Yeah.
Take care. Have a great week.
Bye.
Bye-bye.